Hi everyone. So in this video we are going to study the concept of delay based problems on full adder. So this is a very important concept and very conceptual. If you haven't studied it, you will not be able to do the problem in the examination. And it is a very important concept. Till now these kind of questions haven't been asked, but certainly it will come. Okay, and I want your full concentration, then only we will be able to understand it. So let's start with the first problem. So a full adder is made from two half adder and OR gate. I hope you know how to make a full adder from two half adder and OR gate, right? The delay of for half adder, the delay of producing sum is 20 nanosecond. The delay of producing carry is 30 nanosecond. The delay of OR gate that you will be using that has the delay of 10 nanosecond. Find the delay in receiving the sum and carry of full adder if all the inputs are stable at t equals to 0. That means input A, B, C will be stable at t equals to 0. So these inputs are applied at t equals to 0. Okay. Now this sum will depend on this A and B both, right? This sum will depend on A and B. What is the sum? We don't care. But I know that this sum will be function of both A and B. Say yes or no. This carry will also be a function of both A and B. Actually, sum is A XOR B and carry is AB. But they are certainly function of AB, right? They are certainly the function of A and B. Now, this is your CI. And I am calling this function as, I am calling this as a variable A. So this sum will be function of this A and Ci, right? And this carry will be function of, although it will be a different function, so I should denote it with G. This I should denote with Hi. So this will be a function of, and this will also be a function of A and C. A and Ci, right? So what do you understand by that? That this output will depend on both of these input. And this output will depend on both of these input. Say yes or no, right? Now let's remove it off. Just I wanted to give this point to you that both of the outputs of half adder will depend on both of the inputs. This is what I wanted to tell here. Now these inputs are applied at t equals to 0, right? So they are stable at t equals to 0. So this input is stable at t equals to 0 nanosecond and this input is stable at t equals to 0 nanosecond. Now this half adder has the capability of giving the output at t equals to 0 nanosecond. Say yes or no. Do you agree to this line? This half adder has the capability of giving the output at t equals to 0 nanosecond because inputs are stable at t equals to 0 nanosecond. Now to produce the sum, how much time it will take? 20 nanosecond. Look, inputs were stable at t equals to 0 nanosecond. Now from here to go here, it will take 20 nanosecond time. So this you will receive at 20 nanosecond. And this you will receive after 30 nanosecond because to produce carry it will take 30 nanosecond. So to go from here to here it will take 30 nanosecond. Till now the things are clear. So if this is stable after 30 nanosecond, that means this input is also stable after 30 nanosecond. Say yes or no. This input is also stable after 30 nanosecond, right? Now this input is stable at 0 nanosecond only. This input is stable at 0 nanosecond only. Now output of this half adder is depending on this input as well and this input as well. But this input is being stable at 20 nanosecond, although this is stable at 0 nanosecond only. But this is being stable at 20 nanosecond. So this half adder has to wait for 20 nanosecond. So this half adder will be in position of giving the output at t equals to 20 nanosecond. Are you getting this point? Let's revise it again. We started from here. They were stable at t equals to 0 nanosecond. So this has the capability of giving the output at t equals to 0 nanosecond only. So it will take 20 nanosecond time. It will take 30 nanosecond time. Now this has become stable at t equals to 0 nanosecond. But this became stable after t equals to 20 nanosecond. So this half adder has the capability of giving the output after 20 nanosecond. Say yes or no. Right? Now this sum will take 20 nanosecond and this carry will take 30 nanosecond. So these inputs are stable. The inputs are stable. Both of this was stable at 0 nanosecond, this was stable at 20 nanosecond, but this input has to wait for this guy. So this guy is waiting for this guy. Now both of the guys are stable at 20 nanosecond. Although he was stable at 0 nanosecond, but both came together at 20 nanosecond. Now both came together, now both will go to output. So if both came together and both are going to output, how much time they will take? 20 nanosecond more. So this sum will be stable after 40 nanosecond. Say yes or no. Understood? Now this is 0 nanosecond. This was stable at 0 nanosecond, right? But this output C is depending on both of the inputs. This will take 30 nanosecond time. So this will be stable after 15 nanosecond, right? Because both were stable at 20 nanosecond. So both will take 20 nanosecond they will start going, and now they will take 30 nanosecond time to reach here. So now this input has become stable after 50 nanosecond, and this input has become stable after 30 nanosecond. So this guy was waiting for this guy, that when this guy comes and we start going. So this guy was waiting for this guy, right? Now when they will start going, after 50 nanosecond they will start going, plus how much time they will take to cover this OR gate, 10 nanosecond time. So what will be the delay here? 60 nanosecond. So for the carry it will take 60 nanosecond time, and for sum it would take 40 nanosecond of time. That's the delay. Are you able to understand it? Let's see it again. All were stable at 0. This has the capability of giving the output. So this will give the output after 20 nanosecond, and this will receive the output at 30 nanosecond. So this becomes stable at 30 nanosecond. Let's wait here. Now this, for this full adder, for this half adder, the output is depending on both of the inputs. So both inputs becomes, this input becomes stable at 0 nanosecond only, but this guy has to wait for this guy, because this guy will become stable after 20 nanosecond. So after 20 nanosecond this guy became stable. Now this guy has become stable. Now they both will start going. So to reach till sum they will take 20 plus 20, 40 nanosecond time. To reach till carry they will take 20 plus 30, 50 nanosecond time. Now both are stable at 50 nanosecond, because this guy was waiting for him, right? This guy was waiting for him. Let's just say if you have got, anyhow if you had got 25 nanosecond here, then what would be the delay in CI? That would be 30 plus 10, because this guy will have to wait for this guy, because this guy will come after 30 nanosecond. Are you getting this point? By any chance if you had got a 25 nanosecond here, so this guy would be waiting for this guy, because both will become stable if both are stable. So one guy alone cannot go, because your output is depending on both of the inputs. So stable output it will give only after both are stable. So in this question it was stable at 50 nanosecond. So it gave the output 50 nanosecond plus 10 nanosecond, that means after 60 nanosecond. So carry is received after 60 nanosecond and sum is received after 40 nanosecond. I hope this is clear. Let's move towards next question. So difficulty level will increase. This was the least difficulty level, now it will increase. So this question is given, okay. For t less than 0, a is 0, b is 0, ci is 0. For t greater than 0, a is 1, b is 1, ci is 0. Same question is there, same delays are there, and same question is also there, just I have changed the condition. Do you think there will be any change in the final answer? Well, 98% people will say, sir, there will be no change. Why there will be a change? But there will be a change. Let's check that out. For t less than 0, a was 0, b was 0 and c was 0. So this sum was 0, this carry was 0, everything was 0. This 0 plus 0 will be 0, carry is 0. This 0 is fed here, 0 plus 0 is 0, carry is 0, and this is also 0. So everything was 0. Now 1 1 0. So this has become 1, this has become 1, and this has become 0. So what will be your sum? 1, if you talk about this half adder, 1 plus 1 sum will be 0 and carry is 1. Do you understand this point? In this half adder 1 plus 1 is fed, so sum is 0, carry is 1. So this 0 is going to 0 only, this 0 is going to 1, right? And this 0 is 0 only. This 0 initially was 0 and now it is also 0. So 0 plus 0, this will also go to 0 only. And what will be the carry? This is 0, okay. And what will be the carry here? If 0 plus 0 is being added, so this carry is also 0. Now this 0 has become 1. This 0 has become 1. Basically this 0 has become 1. So what will this output will become? This output will become 1. Now if I ask you at what time you get stable output of sum, what will be your answer? 0 nanosecond. Say yes or no? Because for t less than 0 your output was 0 only, and here also your output is 0 only. This output did not change. Sum did not change. That means sum will be stable at t equals to 0 nanosecond only. So if they are asking how much time they are taking to receive the sum, you will say 0 nanosecond, because it never changed. For t less than 0 as well it was 0, for t greater than 0 as well it is 0 only. The sum did not change. So this is the important point. If you have done in this manner, you would have got 40 nanosecond answer, but that is wrong. Here also you can see, what you can see, here the sum was, what was the sum? 0. What was the carry? 0. What is the sum here? 1 plus 1, sum is 0, but carry is 1. So sum did not change, and if sum is not changing, it will take 0 nanosecond time. So this is the answer for the sum, 0 nanosecond time. This is the answer. What about carry now? So this carry is changing, so that we have to analyze now. So these inputs became stable at t equals to 0 nanosecond, right? Both of the inputs became stable at t equals to 0 nanosecond. So now this half adder has the capability of giving the output at t equals to 0 nanosecond only. But you do not need to see the change here, because this is changing, this is not even changing. So I will need to see the change here. So how much time it will take? To go from here to here, it will take 30 nanosecond time, because for producing the carry, the delay is 30 nanosecond. So this will become from 0 to 1 at 30 nanosecond. At 30 nanosecond. Right? So this has become 0 to 1 at 30 nanosecond. Tell me one thing, this change? No, this did not change. This also did not change. This also did not change. So this was stable at t equals to 0 nanosecond only. This was stable at t equals to 0 nanosecond only, no? Because it did not change. But this came after 30 nanosecond. This guy came after 30 nanosecond. So this guy has to wait. This guy has to wait for this guy, that when it becomes stable. So it will become stable after 30 nanosecond. So 30 plus 10. So after 30 nanosecond, they both will go, and it will take them 10 nanosecond to cross. So 30 plus 10, that means after 40 nanosecond, this will become stable. So for carry, it is 40 nanosecond. So that's the answer. That's the answer of both of the questions. So every time when inputs are given, you need to be aware that what is changing, what is not changing. Let's see more problems. Full adder is made using half adder and two adder. Same things are given. At input A and B are stable at t equals to 0, but Ci arrives after 40 nanosecond. Ci arrives after 40 nanosecond. Find the maximum delay in receiving the sum and carry. So again here, no inputs are mentioned. Again, no inputs are mentioned. So this would be an easy problem. But the thing is, this becomes stable after 40 nanosecond. Now this is stable at t equals to 0 nanosecond, and this is also stable at t equals to 0 nanosecond. The input of both of the adder are stable at t equals to 0 nanosecond. So this has the capability of giving the output now. So the sum will be stable at 20 nanosecond and carry will be stable at 30 nanosecond. Now the input of this became stable at 40 nanosecond. The input of this half adder, one of the input of this half adder became stable at 20 nanosecond, but one of the input of this half adder became stable at 40 nanosecond. So they both will go after 40 nanosecond, because this guy will have to wait for this guy. So both will go after 40 nanosecond, and to go here, how much time they will take? 20 nanosecond more. So 40 nanosecond plus 20 nanosecond, that means 60 nanosecond. And to go from here to here, how much time they will take? 40 plus 30, that means 70 nanosecond. So this guy is stable at 70 nanosecond, and this guy became stable at 30 nanosecond only. Right? This guy became stable at 30 nanosecond only. So this guy will have to wait for this guy. So here 70 nano plus 10 nano, because after 70 nano they will start going, they will have to cross 10 nano. So this will be 80 nanosec. Well and good, understandable. This was also easy question only, just the difference was this came later on. Let's solve this question. I just made the block diagram here. Okay, for t less than 0, A was 1, B was 0, and Ci was 1. And for t greater than 0, this has become 1, but that means this is 1 only. This has become 1, and this has become 0. Okay, so let's see the first condition, 1 0 1. So if 1 0 was there, so sum will be 1, carry will be 0, right? So let's remove it off, otherwise it will make the confusion. So I am analyzing for t less than 0. For t less than 0. So 1 0 1. So sum 1 plus 0 is 1, carry is 0. So this carry is gone here. Now this is 1. 1 plus 1 is 0, carry is 1. 1 plus 0 will be 1. Okay. So here also you can check. Your sum was what? Sum was 0 only. And carry was, your sum was 0. 1 plus 1, sum is 0, carry is 1. Right? And here what will be the sum? In the next condition, the sum will be 1 plus 1. Again sum is 0. and carry is 1. So this sum will become 0 only. Let's check it. A has become 1 only, and this has become 1. So 1 plus 1, this will become 0. This will become 0, and this has become 1 plus 1, this will become 0, and this will become 1, and this 1 has become 0. So this 1 has become 0. This all happened at t equals to 0. About this I am saying. So this has become 0 and this has become 0. So sum 0 plus 0, sum will be 0 only, and carry will be 0. So 0 plus 0, this will become 0. Wait a second, there is some error. 1 plus 1, sum is 0, carry is 1. Okay. This is 0. So this is going to be 0. So 0 plus 0, 0 it is there, 0 it is 1. Okay, so this has become 1. No, this I forgot to check. This has become 0 to 1. So this is 0, this is 1. So what you will get? 1 plus 0 will be 1 only. So both carry and output, both are not changing. So when they are stable at t equals to 0 nanosecond only. The outputs are stable at t equals to 0 nanosecond only. That's the answer. That's it. Both carry and sum. Did you understand this? Here your sum was initially 0 and carry was 1. Now here your sum is 0 and carry is 1. So both did not change. In the mid they could have asked that when this will become stable. These kind of questions could have been asked, because this is changing the state. If this is changing the state, then you can see when it will become stable, because since they are becoming stable at t equals to 0, so this will become stable after 20 nanosecond. This guy will become stable after 20 nanosecond, right? But this guy is stable only, because it did not change. Let's see the next question. This 20 nanosecond, just let's keep it written. And what about this? This will be after 20 nanosecond as well, and this became stable at t equals to 0 nanosecond only. Although they are of no use, but still, what if someone asks? And this became stable at 20, this became stable at this became from 20. Wait a second. Yeah, so input for this half adder, this was stable at 20, this was stable at 10. So this will take 20 plus 20. Sorry, it will not take 20 plus 20 more time, because this is stable at 0 only. But this is changing. If this is changing, so 20 plus 30, this will be stable at 15 nanosecond. Okay. And what about this guy? This guy was stable at 20 nanosecond. So if you are not aware of the concept, you will say that, sir, the Ci plus 1 will be stable after 60 nanosecond. This is what you can say, but that is wrong, because this Ci plus 1 is not even changing. And here you will say that, sir, this is stable after 20, so 20 plus 20, it will take 40 nanosecond. So that is also wrong, because this S is not even changing. If they are not even changing, then what is the concept of, what is the meaning of saying that they are becoming stable after that much time? They are already stable, right? Let's see this question. So same kind of questions can be asked on circuit level as well. So now I have drawn the circuit level. This is half adder, this is half adder, and this is your OR gate. So what you can do, you can convert them to half adder. But why would you do these kind of things in the examination? In the examination, you will be solving it, right? So for t less than 0, A is 1, B is 1, and Ci is 0. So let's analyze it. So 1 XOR 1, this would be 0. 0 XOR 0, this would be 0. Or first you can check here as well, that my sum will be 0 and carry will be 1. Because 1 plus 1 plus 1 plus 1 plus 0, sum is 0, carry is 1. And in this case, sum is 1 and carry is 0. So here both are changing. If both are changing, then things will be different now. Okay. So 0, 0, 0. Now 1, 1. So this is becoming 1. This was the initial condition. Now this is 0, and this is also 0. And this was 1, this was 1. Right. So this was 1 only. This is 0, this is 0. So this would have been 1 only. Okay. Now let's see the solution. Now what will happen? A1 will go to 0, B will go to 1, and C will be at 0 only. right? So 1 XOR 0, this will change, right? So both were stable at, these two input were stable at t equals to 0. So this will change after 10 nanosecond, right? Because both were stable at t equals to 0. So they have the capability of giving the output directly at t equals to 0 nanosecond only. So for traveling them, it will take 10 nanosecond time. So this will be stable at 10 nanosecond. So this input is stable at 10 nanosecond, right? This input here, it is stable at 10 nanosecond. And this was stable, this has become 1, right? This has become 1, which is stable at 10 nanosecond. So this was, now this 0 was already stable at 0 nanosecond, but this guy has to wait for this guy, right? So 1 XOR 0, this will become 1 after 10 plus 20, 30 nanosecond. If this is changing, that means it will become 30 after 30 nanosecond, right? Now this guy was 0 at 0 nanosecond only, and this guy became 1. This guy became 1. Look, it is going from 0 to 0. That means it was stable already. This is already stable. This guy became from 0 to 1. This guy became 0 to 1 at 10 nanosecond. Now you tell me one thing. Where this output is stable? When this output will be stable? At 0 nanosecond or 10 nanosecond? At 0 nanosecond. Why so? Because at 0 nanosecond it is 0, right? At 0 nanosecond this is 0. Now this guy will not wait for this guy. Why is that so? Because this is AND gate, and the output of AND gate will not depend on the other number if one of the number is 0. Say yes or no. Are you getting this point? I hope you are understanding. Or you can directly see that this is 0 only, this is 0 only. So it is not even changing. That means it is stable at directly t equals to 0 nanosecond. If it is not changing, that means it is already stable. What about this? This has become 0, right? This has become 0 and this has become 1. So A has become 0 and B has become 1. So A has become 0, B has become 1. So this output has changed. So both changed at t equals to 0 nanosecond. Both guys changed at t equals to 0 nanosecond. So 0 plus 8. So this will take 8 nanosecond time. So this guy is stable at 0 nanosecond, but this guy is stable at 8 nanosecond. This guy is stable at 0 nanosecond, but this guy is stable after 8 nanosecond. So 8 plus 10, 18. So this will be stable after 8 plus 10. That means 18 nanosecond. Right? And 0 plus 0, this will become 0. So carry will become 0 after 8 plus 10, 18 nanosecond. Let's start again. 1 1 0. In that manner it is written. We got to know that sum and carry both are changing. That means both will take some time to change their outputs, right? 1 is going to 0, 1 is remaining at 1 only. So this output is changing from 0 to 1. So this will take 10 nanosecond because they are stable at t equals to 0. Now this guy is remaining same as it is. This guy is remaining same as it is. What about this guy? This guy is changing at 10 nanosecond. So this guy is stable at 1 at 10 nanosecond. So this guy has to wait for this guy, right? Because output of this is changing. Output of this is 1. So it is changing from 0 to 1. So this guy will be waiting for this guy. So 10 plus 20, 30 nanosecond. Now here if you see, this output is changing from 0 to 1 and this is changing to from 0 to 0 only, because this is simply Ci only. So this is from 0 to 0 and this changed at 10 nanosecond. But the output of this AND gate, did not change. Output of this AND gate is same as it is, 0 to 0 only. So this was already stable at t equals to 0 nanosecond because it did not even change. And what about this guy? So about this guy, so 1 to 0 and 1 to 1. So 1 to 0 and 1 to 1. So both change at t equals to 0. These changes happen at t equals to 0 second only. So after 8 nanosecond, it will take time to reach here. So at 8 nanosecond, this one has become 0. So this guy has to wait for him now, right? Because this output is changing. This output is changing from 1 to 0 now. So if output is changing from 1 to 0, so 8 plus 10, 18 nanosecond. So for answer is, for carry it is 18 nanosecond. And for sum it is 30 nanosecond. And I am pretty hopeful these kind of questions are soon coming in your examination, very, very soon. Let's see this question. So now full adder is implemented using 2-level XOR and 2-level AND OR gate. 2-level XOR and 2-level AND OR gate. Okay. For t less than 0, a is equals to b 0. This you need to solve on your own. B is equals to 0 and ci is equals to 1. So 0, 0, 0, 1, 1, 0. So basically 2 level means here you are collecting your output, that is sum, and here you are collecting your carry, that is AB plus BC plus CA, right? So before that this was 0 only and this was 1, right? So sum was 1 and carry was 0 only. 0, 0, 0. So carry was 0. In this case sum was 1 and carry was 0, and in this case sum is 0 and carry is 1. Okay, so these are changing, these guys are sum is going from 1 to 0, this will change from 1 to 0 and this will change from 0 to 1. So certainly it will take some time, it will take some time to change. Now A has become 1 and B has become 1. These guys have changed at t equals to 0 only. These guys changed at, and C has become 0. C has become 0. So 1 XOR 1, this will become again 0 only. This will again become 0 only. So this is going from 0 to 0. This has become 1 to 0. So this is going from 0 to 0. So at t equals to 0 nanosecond it is stable, and it has changed 1 to 0 at t equals to 0 nanosecond only. This changed from 1 to 0 at t equals to 0 nanosecond only. So this is also stable at t equals to 0 nanosecond. So both of the inputs are stable at t equals to 0 nanosecond. So both can go at t equals to 0 nanosecond. So it will take 0 plus 20. So this output will be stable after 20 nanosecond. That's it. What about this one? So this will become 1. This will become 1 at 15 nanosecond. This will be 0 only, and this will be 0 only, because 1 into 0, 0, 1 into 0, 0. So this changed, this guy changed, and output of this OR gate is depending on him, right? Output of this gate is depending on him. So these two guys have wait for him, although they are stable at t equals to 0 nanosecond only. But these two guys have to wait for this guy, right? Why they have to wait for this guy? Because output is depending on him. If output was not depending on him, they would not be waiting. But output is depending on him. So 15 plus 10. So this will be stable after 25 nanosecond. So that's the answer. Maximum time in receiving S and I. So for S it is 20 nanosecond, and for Ci plus 1 it is 25 nanosecond. So these kind of questions can be coming in your examination. So you should be able to solve. Let's see if there are any other problem. No. So these kind of questions can come in your examination, and you should be comfortable with these kind of analysis. Okay, so we saw a lot of problems. If you are able to understand, that's pretty good. Just revise it once again. Just revise everything once again, and you will certainly feel pretty good about it. And it will help you a lot in binary parallel adder. When we study binary parallel adder, it will help you a lot. There 4 bits will be coming all together. So there also some good analysis will come up. In one analysis, there will be no inputs given, like in this manner. No inputs are given, A, B, C, D. So simple analysis was there. But if inputs are given, then the things changes. Then you need to see the previous state as well, that if anything is actually changing or not. If nothing is changing, then let it be. Okay. So yeah, that's it. And we have already launched our full course for digital electronics. So if you are interested in studying digital electronics in this much of depth, then you can certainly come to our course. So digital design course for placements as well has been launched, and for digital electronics course also has been launched for GATE. So if you are interested to learn in this much depth, and we are giving it in just 199 rupees. Okay, you need to apply the code Titans40. So you can visit our website, and there you can purchase the course. Okay, it is very, very cost effective. Like, it is taking a lot of efforts in designing these kind of problems, thinking of these inputs, but I just want to give the feel of digital electronics to all of you. So if you are thinking to purchase the course, then you can purchase the course. Okay, then thank you very much.